All right, let's do a video real quick for 12.5, surface area of a cone. So hope you're doing okay this morning. Remember, quiz on Friday over 12.2, 12.3, 12.4, 12.5. You will have access to your book. So, if you have trouble remembering what we're doing to find the surface area of some of these figures, you'll have reference to that. You just make sure you know how to do it with the given information. Like, if you have the formulas for these things, can you plug in the information and find some of the lengths, like the apothem length or something like that, or the slant height length, things like that. So I'm going to try to keep this one short for you today, and it's nothing drastically new, but a little bit of a different concept with the cone here. So I'm going to put it on my screen. So hopefully you can see that now. So we have a cone. A cone, basically, as you know, is something that looks like this, three-dimensional. So I'm not very good at drawing those, but you get the idea. It's a cone. So we need to try to find the surface area of this cone. So again, let's think of this as being the lateral area, the area of this, around the side of this cone, and then add that to the area of the base, in this case, which would be a circle. So we know how to find the area of the circle. We've done that before. That's just pi r squared. So finding the lateral area of this thing, the lateral surface area of this cone, is where I need the new information for today, basically, okay? Well, if I were to cut this out, if I were to slice this cone and then unroll it, I would get something that looks kind of like this. Okay, so I get a sector of a circle. And in addition to that, let's say that represents the base. So I have a base right here, and this is the lateral area. We'll just call that the sector of circle. Okay, so the question is how do I find the lateral area? Well, if I could just figure out the area of this, I would be fine. All right. We kind of did something similar to this, but we would need like maybe the measure of this angle right here in order to figure out the area of that sector, because it would just be that percentage of the whole circle, right? But we don't have that usually when I'm doing this. So I'm going to show you how we're going to find this. There's two ways to think of it. One, the confusing way. Two, not so confusing. And again, if you're just the type that says, hey, just tell me what I need to know, you could skip all this. This is just kind of, in case you want to know why. You don't really need to know why so much, but just in case you do. Okay, so I'm trying to find the lateral surface area of this cone. So wouldn't it make sense that if the lateral surface area of the cone, which is the sector, and so I'll just write that, and I would make that a ratio, like that, the area of the sector to the area of the circle. And wouldn't it make sense to say, and this again is going to be the lateral height, this is the radius of the base, so like that, and this is the lateral height up there. Okay, so wouldn't it make sense then to say that the length of this arc would be same proportional? So we'll say the length of arc would be the same as the ratio of the circumference of the whole circle. Circumference of circle. So I've kind of set up a proportion here, and think about it. The ratio of the area of this thing would be the same as the ratio of this length to the whole way around, like that. Think of the area of the sector and the area of the whole circle as a ratio right here. Okay, and think of the length of this arc, the length of that arc, as a ratio to the circumference of that whole circle. You would think those two things would be proportional, and they are. Okay, So I can set up a proportion. So now it's just a matter of finding, what I'm looking for is how do I find the area of this sector? That's the lateral area. Again, this is the why I came up with the formula that I'm going to use. Well, what's the area of the sector? That's what I'm trying to find. But what is the area of the circle? How do I find that? The area of the circle, in this case, so I have the area of the sector. The area of the circle would be pi r squared. Well, what's r in this circle? It's the slant height, L, right? So this would be pi L squared, okay? What's the length of this arc? Well, that would be part of that circumference of that circle. But if I were to think about it in terms of the base, this length, and I'm going to try to erase some of these things here. Okay, good. This length is going to be the same as the circumference of this whole circle. And if you were to cut it out, you would see that that arc length is the same as the circumference of the base. So what is the circumference of the base? That's, oops, back to the pencil, that's 2 pi r, okay? That's how circumference is 2 pi r. So the circumference of this circle right here is 2 times pi times that radius. And that's what I put right there. Okay, that would be a ratio to the circumference of the whole circle. What's the circumference of this whole circle? This whole circle would be 2 pi times the slant height. Now I can just solve for the area of that sector and get, by cross multiplying, that this is the area of the sector is equal to pi L squared times 2 pi r, sorry, that's not very neat, over 2 pi times the slant height. And there it's just a matter of simplifying. You could cancel these pi's, you could cancel those 2's, and so that's multiplying. So, and then this L squared over L is just the slant height. So really what I'm left with is that the area of the sector is equal to pi times the radius times the slant height. So if I'm trying to find the lateral area of a cone, I just take the radius times the slant height times pi. Okay, now that's the hard way of trying to figure out how did I come up with a way to find the lateral area of a cone. That's the hard way to figure out how I came up with this. My way, the easier way, I think, is, okay, let's think of this as in terms of what I've been doing. Normally, how have I been finding the lateral area of any of these 3D figures, right? I've been taking half of the perimeter and multiplying it by the slant height, right? So I have a slant height here, and normally I've been saying, okay, I take 1/2 the perimeter times the slant height, right? Okay, well, let's just think of it in that terms of how I'm going to find the lateral surface area of a cone. So if I did think of it this way, what's the perimeter? What's circumference? That's 2 pi r times the slant height, right? So what's 1/2 times 2? That's 1. So I'm left with the lateral surface area of a cone being pi times r times the slant height. All right, so that's my way of thinking of it, more in terms of what I've been doing. And what I have been doing is saying, okay, the lateral surface area of something is half the perimeter times the slant height. So in this case, the perimeter is circumference of the base, which is obviously 2 pi r. So 1/2 times 2 pi r is just pi r times the slant height, pi r times the slant height. So that is how I'm going to find the lateral area of a cone. Let's just put this down here as key concept number 1 for today. Key concept number 1 is lateral area is pi times r times the slant height. Okay, now if I wanted to find the total surface area of a cone, which will be key concept number 2 for today. These should be in your notes for sure. Think of this cone. Well, I found the lateral surface area of this cone by taking pi r times the slant height. Now I just need to find the area of the base. How do I find the area of a base, which is a circle? It's pi r squared, right? So in order to find the surface area of a cone, I would need to take the lateral surface area, which is pi r times the slant height, and add it to the area of the base, which in this case today is a circle, so pi r squared. So key concept number 2 for today, surface area of a cone is pi r times the slant height plus pi r squared. Okay, let's do some problems now. Hopefully that we'll keep those in the frame for you. Let's try number 1 on page 708. So here is number 1. It says find the surface area of each cone round to the nearest 10th. So I've got a cone, and they drew it sideways for some reason, okay? And I've got this. These are right cones. If that altitude is perpendicular to that base, that makes it a right cone. If it's not a right cone, they called it an oblique cone. But we're dealing mostly today with right cones, so I don't have to worry about the other oblique cones yet. Okay, so here we have number 1. It said that the radius of this base is 10 and the slant height, excuse me, is 17. So how am I going to find the surface area of a cone? I'm going to take the fact that pi times r times the slant height plus the area of the base, which is pi r squared. And then let's just plug in my information. Surface area of this thing would be pi times the radius 10 times the slant height 17 plus pi times the base, or the radius, sorry, is 10 squared. So these are really easy. I don't even need a calculator. This is 170 pi plus 100 pi. So the surface area of this thing is 270 pi. Now I need my calculator. 270 times pi is 848.2. 848.2, and we're dealing in centimeters. There you go. That's number 1. Pretty simple, I think. As long as we know how to find the lateral surface area of the cone, I should be fine. It should be no different than what I've been doing. Okay, let's try another one. Let's do number 2. Okay, this time they drew the cone right side up, so we will too. We've got an altitude of 12 and a radius of 10 again. Thank you for making this easy. Who said that this should be hard? Okay, now I need to find the slant height. How am I going to do that? It didn't tell me what it is, but I have a right triangle there. So 12 squared plus 10 squared should give me the slant height. So let's just do Pythagorean theorem real fast. Right? 144 plus 100 gives me the slant height squared, so 244. So the square root of 244 would be the slant height. Let's approximate that. 244, 15.62. 15.62. So my slant height is 15.62. Okay, so to find the surface area of a cone, I need to know that I need to find the lateral area, which is pi times the radius times the slant height. Add that to the area of the base, which is pi r squared. Okay, so that is my formula for finding the surface area of a cone. Here we go. Let's plug in what I know. Surface area should be equal to pi r, in this case 10, times the slant height, which we said is 15.62, plus pi r squared, so 100 pi. 10 squared is 100. Okay, this is easy, no calculator yet. This should be 156.2 pi plus 100 pi. Surface area should be 256.2 pi let's do that on my calculator. 256.2 times pi. And I get 804.9. 804.9. 804.9, we're in feet, so square feet. That's the answer. Okay, pretty easy. I'm going to pause it for 1 second and then come back. Okay, sorry about that. Let's go back to doing one more, because they're going to have some problems where it's going to give you the surface area and you're going to have to find like the slant height or the radius. So let's do one of those. Let's do, I know this is part of the homework, so I'll do one of those ahead of time. Let's do number 13, where it says find this, or it says the surface area of a cone is 120 square meters and the radius is 14.5 meters. Find the slant height. Okay, so I've got a cone. I need to find the slant height. It told me the radius is 14.5. All right, 14.5 is the radius. And it told me the surface area of the cone. So I'm just going to write out here that the surface area of the cone should be equal to the slant height, which we have said multiple times now is pi r times slant height. And then we are going to add that to the area of the base, which is pi r squared. Okay, now let's just plug in the numbers that I have and the numbers that I know. It told me the surface area is 1020. So 1020 times, it should be equal to the radius, 4.5 times the slant height. So I'm just going in here and putting in what I know, 14.5 squared. Okay, now it's just a matter of solving for the slant height L, right? So let's do that. This is 1020. This should be 14.5 pi times the slant height plus 14.5 squared. 210.25 pi. All right, let's simplify. Let's take these terms and multiply by 5 before we solve for the slant height, or by pi before we solve for the slant height. So that one's 660.52. 660.52. And 14.5 times pi would be 45.55. 45.55 times slant height. We still have 1020 over there, so now it's just a simple algebra problem. Let's subtract 660.52 from 1020. Minus what? 660.52. I get 359.48. 359.48. Okay, now let's divide by 45.55. Take that and divide by 45.55. And I get 7.9 basically. So the slant height is 7.9 and we are in meters. There you go. That's all there is to it. I don't think there's anything new for today. It's just a matter of how do I find the lateral area of a cone and then add that to the area of the base, which we know how to find the area of a circle, since the base of a cone is a circle, pi r squared. So the lateral area is pi times the radius times the slant height. That's how I find the lateral area of a cone. So nothing new today. It's just a different way to think about it. All right. See you tomorrow. Text me if you have any questions.